total internal reflection is possible only when light is traveling from denser to lighter medium. When a ray of light enters from a denser medium to a rarer medium, it bends away from the normal. For example, the ray A01B is partially reflected and partially transmitted or refracted. For example, the ray AO2B is partially reflected and partially transmitted or refracted. As the angle of incidence increases, so does the angle of refraction, till for the ray AO3, the angle of refraction is pi/2. The refracted ray is bent so much away from the normal that it grazes the surface at the interface between the two medias. The angle of incidence corresponding to an angle of refraction 90 degree, say angle AO3N, is called the critical angle, denoted by IC, when light is traveling from denser to lighter medium. According to Snell's law, refractive index equals sin I by sin R. This implies refractive index of the medium 2 with respect to 1 equals sin I by sin R. For critical angle, I equals IC and R equals 90 degree. This implies N21 equals sin of IC. For values of I larger than IC, Snell's law of refraction cannot be satisfied, and hence no refraction is possible. When the I larger than IC, the ray gets reflected and follows the laws of reflection. The incident ray is totally reflected from the surface of the denser medium, and this is called total internal reflection. Let us take a demonstration for total internal reflection. Take a glass beaker with clean water. Now make it a little turbid by adding detergent to it. Now take a laser pointer and shine its beam through the turbid water. Now we can see its path inside the water. Shine the beam from below the beaker such that it strikes at the upper water surface. We will find that the beam undergoes partial reflection and partial refraction. We will not see the path of beam in air, but we can see the laser point on the wall and on the table. Now direct the laser beam from one side of the beaker. It strikes the upper surface of water, making small angle with the horizontal. By adjusting laser beam, we find the angle for which the refraction above the water surface is totally absent and the beam is totally reflected back to water. Pour this water in a long test tube and shine the laser light from top. Adjust the direction of the laser beam such that it is totally internally reflected every time it strikes the walls of the tube. Let us study about mirage. Mirage is a naturally occurring optical phenomenon in which light rays are bent to produce a displaced image of distant object. Some phenomena can also be observed in the deserts. It appears that there is some water body in the desert. A tree is seen by an observer at its place when the air above the ground is at uniform temperature. This is also an example of mirage. Let us study about diamonds. Diamonds are known for their spectacular brilliance. Their brilliance is mainly due to the total internal reflection of light inside them. The critical angle for diamond-air interface is approximately equal to 24.4 degree. This is very small angle. Therefore, it is very likely to undergo total internal reflection inside it. Let us study about prisms. Prisms designed to bend rays by 90 degree and 180 degree, or to invert image without changing its size, make use of total internal reflection. In these two cases, the critical angle IC for the material of the prism must be less than 45 degree. Let us study about optical fibers. Light undergoes successive total internal reflections as it moves through an optical fiber. Nowadays, optical fibers are extensively used for transmitting audio and video signals through long distances. Optical fibers too make use of the phenomenon of total internal reflection. Each fiber consists of a core and cladding. The refractive index of the material of the core is higher than that of the cladding. When the lamp is switched on, the light travels from the bottom of each fiber and appears at the tip of its free end as a dot of light.